Problem 320, generalized abbreviation. So for this problem, we are giving words generalized abbreviation that can be constructed by taking any number of non-overlapping and non-adjacent substring and replacing them with their respective lengths. So let's just try to understand it. For this one, it's really difficult to understand, but let's just try to understand the examples maybe. In this example, with A, B, C, D, E, we can use A, 3, and E, it is okay. And 1, B, C, D, and 1, it is okay. We can use 5, it is okay. Yeah, but for something, we cannot use adjacent two numbers like 2 and 3, it is not okay. Or we cannot use overlap. So for example, 2, D, and E, because there is overlap, but we cannot use overlap. So yeah, because this gonna be the length gonna be 5, but 2 D the length gonna be 6, so there's overlap, so this is not okay. Yeah, now let's just check the first example. If we have a word, so definitely we have so many different kind of cases. So that is a generalized abbreviation, and because there are so many cases, so we might think about solving this problem by using backtracking. So the idea is that, for example, this is a word, we can use for, or we can use 3D, or we can directly use a word, or we can use WOR, and the last one we're gonna represent as 1. Yeah. So there are so many different cases, and how can we find so many different cases? And we're gonna use a backtrack to find all cases. So I'm gonna prepare the result, and N gonna be length of the word. Yeah. So the idea is that. For example, if we are having this word, so what are we gonna do? We're gonna have two decisions. So the first decision is we're gonna take a word. So what left behind is ORD. Yeah. So this is one case. So for next one, for ORD, we can continue to do it. We can take out O, and what left behind is R and D. Yeah. So this is one thing. So another thing is that because this is word, and we can just iterate from 0 to, for example, the length of the word is from 0 to n-1. We can iterate the word. So this means we can try so many different cases. So for example, we can, if we use like, yeah, let me check. If we use, so for example, if we use a 1, so what's gonna happen? If we use a 1, so what left behind is ORD. Yeah. So this is one case, but we also have other cases. So what about if we use a number 2? So what left behind is R and D. Yeah. So what about if we use 3? So what left behind is D. Yeah. So what about if we use 4? So what left behind is nothing. So yeah, because so for example here, we have a number 4. This is also okay. Yeah. So for this word string, we have two check. Basically. We can check the characters one by one. So for example, we can take out the character one by one, or we can directly use numbers like 1, 2, 3, and 4. Yeah, so this is the idea of backtracking, and then we're gonna continue for this backtracking until we find all different cases. Yeah. Now let's just define the backtrack function. So inside, I'm gonna prepare an answer. So the answer gonna be an empty string and index I. So if I equal to n, so this means I've already found it. So I'm gonna put it inside the result and gonna have a return. So the backtrack inside is gonna be an empty string and index 0. So after the backtrack, I'm gonna return this result. Yeah. So for giving index, so the index is gonna start from 0. So for a given index, what I can do? So first of all, I'm gonna start from index 0. I have two decisions, so I can go to the backtrack. It's gonna be I plus 1, and the answer gonna be an empty string, gonna plus this word I. Yeah, because I need to take this word W. So for example, and then I'm gonna update the index to I plus 1. So this is one case. So for another case is that I'm gonna check the J. Yeah, but before I check this J, it means I'm gonna use the numbers. Yeah. So if I were to use numbers, it means the character before my current number must be a character or must be nothing. Yeah. So I need to have a tag. So for this for loop, so if not answer, this means if it is empty or there's something inside, and answer -1 is is alpha. So this means if it is an empty string, or if it has something inside and before it is a lowercase letter. Yeah, if it's alpha means it is a lower is an alphabet. Yeah, basically it has lowercase or uppercase, but for our cases it is just lowercase. Yeah. So if it is meet the condition, I'm gonna use the for loop and continue the backtracking. So for j in range I2, length of the word. Yeah, and then I'm gonna call the backtrack. So it's gonna be inside it's gonna be z+1, because here this is I+1 and here it is z+1, and we're gonna update the string. So it's gonna be answer plus, we're gonna turn this to string z minus I+1, because this is z+1, this is I, z+1 minus I, so this is z+1 minus I. Yeah, so this is everything, I think. Yeah, I think this is everything. So currently this is I, so for example this I can be 0. Now this z+1 gonna become 1, and we're gonna take a number 1. Yeah, until we take all the different cases. And now let me just run it. I did something wrong. Let me just have a basic tag. So concatenate the string with integer. I used this is a string and the word I. Yeah, the word I must be a string. I did something wrong. I don't know why. Let me. Yeah, let me just check what happens. So I+1 and answer and word I. Yeah. So this is 1 and empty and W. I did something wrong. Yeah, I mean I want to concatenate a string with a string, but currently it is a integer. I don't know why it is a integer, because my answer is a string basically, and this word I must be a string. I don't know. Let me just check. So let me directly use answer. I don't know. It is still wrong. Yeah, I think this is why I did it wrong, because the first place is the second place. So let me just use the index 0 with the empty string. So in this case it should be okay. So I'm gonna use the index I and answer. Yeah. Now here answer gonna plus the word I. Now I think it is the same position. So this is an integer and this is a string, integer string, and if it equals to n, I'm gonna put it inside the result, and this is the backtracking, and this is another case. Yeah. Now let me just run it. Now as you can see it works. Now let me submit it. As you can see it's pretty fast, and it passed all testing cases. And for this problem, because for example, let's just check the time complexity. So basically we have two different cases. So for example, we're gonna call the backtrack, go to the next, or we're gonna use a for loop to check the next. Yeah. Or we're gonna use numbers. Yeah. So this means for each of the character, we can choose it or not choose it. So basically, the time complexity gonna be 2 to the power of n gonna be the length of the word. It's gonna be 15. So basically, it's gonna be n times 2 to the power of n. Yeah, I think that's all about it. Thank you for watching. See you next time.